For day 4 notes, I'm just going to have you go ahead and fill in this first part. Dilations preserve angle measure, but not the length of the sides. And then for the vocabulary and definition part here, you're just comparing the different pieces. So it looks like here went from a smaller figure and they enlarged it because the primes are here. So this was the pre-image, this is the new image. So you might want to pause this part, copy this part down, and then start again. Okay, then at the bottom we have a dilation is an enlargement if the scale factor n is greater than 1. The dilation is a reduction if the scale factor n is between 0 and 1. So these two pieces of information are pretty important. Okay. Down here it says, is the dilation of this triangle to this triangle an enlargement or a reduction? So it looks like what I did was x prime over t prime. So we can find x, okay, well here's x to t, and then x to t. And so that would be 4 plus 8 to get the entire length there, and then just the 4 to get the small length. And they got 3. Since 3 is a whole number, which is greater than 1, has to be an enlargement. And we can see that. I mean, if I gave you this little triangle and then I gave you this big triangle, obviously little to big is an enlargement. Then for the back, you have to actually practice that. So at the very top, I gave you how the rule usually looks. I think it's a little bit easier to see it right here. This means, like, what are the coordinates of the vertices of this triangle? If you dilate it by 2, okay, so that means if it's 2, it's a whole number greater than 1. So you're going to multiply all of these by 2. And then it says graph the image and the pre-image of the triangle. All right, so first of all, the scale factor is 2. The rule says that we are going to say dilation, or dilate, by a scale factor of 2. And we're going to do this to triangle PZG. And this equals, okay, so this part right here, this nx, ny, this n is your scale factor, whatever this is. So in our case, it's 2. So you're going to multiply the x number, x coordinate, by 2, and you're going to multiply the y coordinate by 2. So is this a reduction or an enlargement? It is definitely an enlargement. Okay, so first thing I'm going to do is I'm going to write down all my points. So I've got P, G, and Z. P is 2, negative 1. G is 0, negative 2. And Z is negative 2, 1. If I multiply this by 2, and this by 2, and this by 2, and this by 2, etc., then my new points would be 4, negative 2, 0, and negative 4, negative 4, and 2. So all I did, multiply x and y by 2. So over here, I graph them. So I graph the original. Okay, now, when I graph the primes, this should be a bigger triangle. So for P prime, and then G prime, lastly, z prime. But we can see it's an enlargement of the original.